A log with a circular cross-section is being prepared for milling. The log is to be cut into 5 usable pieces, one large beam with a square cross-section, square, and 4 sideboards as shown in the diagram below. Determine the exact radius of the log. Well, if we look at this triangle here, let's just draw that out over here. That is 40 and that is 40 because we know it's square and we've got the 40 measurement just there. And so this is the diameter of the log, and the diameter is going to be the square root of 40 squared plus 40 squared. So the diameter is going to be the square root of 3,200. And so the radius is going to be half of that. So we could use our calculator to simplify that for us. We don't need to do it manually. We could do it manually easily enough, but I'm in standard, and so I am going to do 0.5 times the square root of 3,200, and that gives me 20 root 2. And that would be in centimeters. Using the variables defined in the diagram, show that the cross-sectional area in square centimeters of a single sideboard is A of x is 2x root 400 minus 40x take x squared. And those sideboards are these ones just here. So from the diagram we can see that the area is equal to xy, and we can see the x there and the y there, and that's why that works. We need to get at this y, and we can use this triangle just here. Now if I draw that triangle out, we can see that's a half y. This one here is going to be the radius, so that's 20 root 2. And then this one is going to be 20 plus x, so that's half of the 40, add the x. So using Pythagoras, half of y squared is 20 root 2 squared, take away 20 plus x squared. So 1/4 y squared is going to be 800 take away 400 plus 40x plus x squared. So 1/4 y squared is going to be 400 minus 40x take x squared, and so half y is going to be the root of 400 take 40x take x squared, giving us that y is twice root 400 minus 40x take x squared, and therefore the area is just going to be 2x root 400 minus 40x take x squared as required. Use calculus techniques to determine the dimensions x and y that maximize the cross-sectional area of one sideboard. So we have that the area is 2x 400 minus 40x take x squared to the power half, and that is a product. U is 2x, V is 400 minus 40x take x squared to the power a half. So du dx is equal to 2, and dv dx is going to be a half of 400 minus 40x take x squared to the negative a half, multiplied by the differential of the inside, which is negative 40 take away 2x. And so what we get is negative 20 minus x. That's just doing the half times this bit. Sorry, it'll be plus x because I'm going to put it all over. The square root of 400 minus 40x take away x squared. And therefore dA dx, of course you can do a lot of this on your calculator, you don't need to do it manually as I've done it. So dA dx is going to be v du dx, so that's going to be twice the square root of 400 minus 40x take away x squared. Now in the formula it's a plus, but remember this one's a minus, so it's going to be take away that one times that one. So that's going to be 2x, 20 plus x, all over the square root of 400 take 40x take x squared. And we really want dA dx to be equal to 0. Now I've gone ahead and solved that on my calculator, as you can see over here, because you can't really solve that manually easily. And there's a negative value and a positive value. It has to be the positive value, which we'll call 5.62. So x is 5.62. To get the corresponding y value, we're just going to substitute into our expression for y, which is this one up here. And we won't actually ask for the area, just the x and y values. So x is 5.62, y is 23.99, and those are all in centimeters.